Okay, so let's move to the next question, which is in here. Find the antiderivative of a given function. Okay, so these or this part or this question is question 9 or part 9, exercises from 21 to 29 and page 329. Okay, so let's see how we can solve these questions. So let's go directly to our PPT. That's it. So finding the antiderivative or the integration. So in here, first of all the time, for the first question, let's start with the question 21, for example. If you have rational function, you have to think about two things. Okay, first of all, the inverse functions, tan inverse, sine inverse, cosine inverse, all of these things. Okay, or you can think about the ln, because the ln also we have, if we have the function in the denominator and the derivative of the function in the numerator, that means we have ln, or we can find the integration by using the ln. Okay, so in here, for example, this is not one of the rules of the sine inverse, tan inverse, or cosine inverse, or all of these things. Okay, we can think about the ln, because in here, the derivative of the denominator, the derivative of x squared, this is equal to 2x. Now I have 4x in the numerator. So the 2 is missing from the numerator. So what to do to solve the question? I can basically say that this is equal to 4. So this is question 21 we're talking about here. So we can take the 4 outside. Then say I have x over x squared plus 4. Okay, so now the derivative of the denominator is 2x. In here we have only 1x. Okay, so to do that, in here I can multiply by 2 and divide by 2. Okay, so now the derivative of the denominator is 2x, and you can find it in the numerator. Now multiplying 2 and dividing by 2, it's like you did nothing. Okay, because it's equal to 1, so it's like you multiplied by 1. So 4 over 2, this is the x. So 4 over 2, which is equal to 2. The integration of this, now the derivative of the denominator, you can find it in the numerator, which is in here ln the absolute value of x squared plus 4, 4, sorry. Okay, and then plus c. Okay, so now let's move to question 22. So in here, in this question 22, we can see that this is the integration of a 3 over 4x squared. So in here, this is 4x squared. So let's think about the ln function, for example. If we find the derivative of the denominator, it will be in here 2 multiplied by 4, which is equal to 8x. We cannot find any 8x in the numerator, or even part of it. We cannot find. We have only 3. And we cannot multiply by, for example, by 8x and divide by 8x. We cannot do this. Okay, so what to do to solve this question? So in here, we can say that this integration, okay, we can think about the second choice, which is the inverse functions, tan inverse, sine inverse, etc. Now, if we took in here the 4 as a greatest common factor and the 3 outside, so that will leave me with 3 over 4 integration of 1 over, okay, this is 1 plus x squared. Okay, now after taking the 4 as a greatest common factor. Now, the derivative, if you remember the rules of tan inverse, the derivative of tan inverse x is equal to 1 over 1 plus x squared. So now, that means in here I have 3 over 4 multiplied by tan inverse of x plus. Okay, that's it. Basically, it's very easy to think about the concept. So just we took in here the numbers outside. So in here for question let's move to question 23. Okay, so this is 23. So the integration of cosine over sine, which is equal to the integration of, or without doing this. Okay. So in here, let's think since we have a numerator and a denominator, let's think about the len. Okay, the derivative of sine is cosine. So in here, the integration cosine x over sine x dx. This is equal to len absolute value of sine x plus cos the derivative of sine. We can find it in the numerator, which is cosine. Okay, so let's see another question. Let's move to question 24. Let's see how we can solve it. So question 24. The integration of 2 cosine x minus square root of e to the power 2x. This is very easy. We can rewrite this as 2 cosine x minus e to the power 2x to the power 1 over 2. Now 1 over 2 multiplied by 2x, this is equal to integration to cosine x minus the 2 with 2 they will be eliminated, so 2 with 2 eliminated together, so that will leave me with e to the power x dx. So now the integration is equal to, now cosine x, the integration of cosine is equal to minus sine, so sorry, okay, sine, not minus sine, and we have the constant which is 2, so sine x, because the derivative of sine is equal to cosine x minus e to the power x over 1, then a plus, and that's it. So this is sine, not minus, be careful. Okay, so directly let's move to the next question, which is question 25. Okay, so we have integration of e to the power x over e to the power x plus 3. Again, we have a numerator and a denominator. Let's think about the len rule. So in here, the derivative of the denominator is equal to e to the power x. So I can find the derivative of the denominator in the numerator. So directly, the integration of e to the power x over e to the power x plus 3 dx. This is equal to len the absolute value of e to the power x plus 3. Okay, plus c. Because the derivative of the constant is equal to 0, and this is e to the power x. So whatever was the constant, it will be the same. So in here, let's talk about the next question, question 26. 26. Okay, now we can use in here, I have a numerator and a denominator, but the derivative of the denominator is equal to e to the power x without a plus 3. So what to do? We can think about the distributive property. So in here, the integration, this is equal to e to the power x over e to the power x plus 3 over e to the power x dx. Because in here, if we have a plus b over c, this is equal to a over c plus b over c. Okay, but be careful, the opposite is not correct. So if you are saying c over a plus b, this is not equal to c over a plus c over b. Be careful from that. So just to avoid any confusion, this is correct, this is incorrect. So in here, e to the power x over e to the power x plus 3 over e to the power x. So this is 1, and this is 3 over e to the power x. So this is equal to the integration of 1 plus 3 times e to the power minus x dx. Now let's find the integration. So this is x for the first one. For the second one, plus 3 e to the power minus x divided by minus 1, then plus. If you would like to take the minus 1 over here, you can do this. So it will be x minus 3 e to the power minus x plus c. This is about simplifying. Okay, let's move to the last two questions. So in here, if we have, so question 27. Okay, we don't have something like in the derivative called product rule. So we have product of two functions here, x to the power 1 over 4 multiplied by x to the power 5 over 4 minus 4. So we don't have product rule. So we can use the distributive property from the beginning. Then we will see what will happen with this. So x to the power 5 over 4 multiplied by x to the power 1 over 4. We can just add the exponents since we have the same base. So 5 over 4 plus 1 over 4, this is equal to 6 over 4. Okay, so minus 4 multiplied by x to the power 1 over 4. Okay, and then dx. So let's find this directly. For sure in here we can simplify this. So divided by 2, this is equal to 3. Divided by 2, this is equal to 2. Now the integration of x to the power 3 over 2, it will be x to the power 3 over 2 plus 1, which is 2 over 2. So this is 5 over 2. Now minus 4 x to the power 1 over 4 plus 1, which is 4 over 4. So this is 5 over 4 divided by 5 over 4 plus c. We can simplify this. We can write it as x to the power 5 over 2 minus, now in here 4, we can flip the second one, so it will be 4 multiplied by 4, which is going to be 16 over 5 multiplied by x to the power 5 over 4 plus c. Okay, so the same thing if you would like to solve question 28, it will be the same concept exactly. So that's it. This is for part 9. So I will show you the answers now. If you would like to practice, if you would like to make sure that your solution is correct, you can use these answers. So in here, these questions from 21 to 26. Okay. And over here we have questions 27 to 28. Okay. Then we have over here, we have questions. Oh, خلاص. No, it's from 21 to 29. That's it. Mhm. Okay, so in this question, which is the last question 29, this is finding the derivative of len. You remember that the derivative of len is the derivative of what inside the len over what inside the len. So in here, the derivative of what inside, so let's solve this directly. So in here, this is the derivative of len sec plus tan. So derivative d over dx of len sec x plus tan x. Okay, so this is equal to the derivative of what inside? The derivative of sec is equal to sec x tan x plus the derivative of tan, which is equal to sec square x over, okay, so it will be sec x plus tan x. Now we can take secant as a greatest common factor. Okay, so this is equal to secant x multiplied by tan x plus secant x, okay, divided by secant x plus tan x. Okay, then we can simplify. Since we have this the same as this, we can simplify them together, so the derivative is equal to secant x. That's it. So in here we have finished this part. So inshallah next video we'll talk about part 10. So see you then.